Hi, today we'll be discussing a very important subtopic of the topic of time speed distance. So, we'll be studying relative speed. Now, from this subtopic relative speed, you get questions in CAT. In fact, from time speed distance, you definitely get questions in CAT examination. So, let's start. So, let me explain physically what do you mean by a relative speed. Say, if two cars are moving towards each other, so relatively at what speed they are approaching towards each other. Okay. Or similarly, if two cars are moving in the same direction, so relatively at what speed they are approaching towards each other. So that's what the relative speed is. So that is what by language. So let's understand it mathematically. What does it mean? Okay. So let's start. Let's say there is a city. So there is a city Ranchi, and there is another city Jamshedpur. Now the distance between these two cities is 120 kilometers. Say. All right. Now let us assume that from Ranchi a person starts at the rate of 30 km per hour at 6 am, and from Jamshedpur another person starts at the rate of 10 km per hour at 6 am. Fine. So the time is 6 am, and what is the distance between these two? The distance between these two is 120 km. All right. Now let us understand what will happen after 1 hour. So after 1 hour, that means at 7 am, this person will travel towards this at the rate of 10 km per hour. So after 1 hour, it will travel how much time? How much distance? This is 10 km. So at 7 am, it has traveled 10 km. In the same way, if you look this side, at 7 am, it will travel 30 km because it has traveled 1 hour. So say for example, it has traveled 30 km, and now it is 7 am. Now can you see that initially the gap was 120 km per hour. Now this person has reduced a gap of 30 km, and this person has reduced a gap of 30 km in 1 hour. Fine. So what is the gap reduction after 1 hour? Initially what is the gap? 120 km. Now the reduction of gap is how much? 30 plus 10, 40 km. What is the gap now? 120 minus 30 minus 10, so 80 km. Fine. So other way around, can I say that these two runners or these two cars are moving towards each other, and in 1 hour they have reduced a gap of 30 plus 10, 40 km. So they are approaching towards each other at the rate of 40 km per hour. All right. So can we understand this, that if both the cars are moving towards each other, so relatively they are reducing the gap of how much? Sum of their speeds, and that's what the relative speed is. So if I can formulate, the formulation is what? If two cars or two runners running in opposite direction, so what is the relative speed? The relative speed is sum of their speeds. Okay. So if if running in opposite direction, the relative speed is how much? relative speed is sum of the speeds. Okay. All right. Now, so the next question is, after how many hours they will meet? So after how many hours they'll meet, let us understand this way. Through unitary method, let us understand this. So in 1 hour, they are reducing a gap of how much? 30 plus 10, 40 kilometer. All right. So meeting means what? Meeting means the gap should be 0. So at 6 a.m., the gap between these two cars was 120 kilometer. In every hour, they are reducing the gap of 40 kilometer. So in how many hours they will be reducing the gap of 120 kilometer to 0? And if the gap is 0, that means they are meeting. Is that clear to you? Okay. So if I go for unitary method, can I say that 40 kilometer is reduced in 1 hour? So 120 kilometer will be reduced in how many hours? So this comes out to be 1 by 40 into 120. So this becomes 3 hours. All right. So that means after 3 hours they'll meet. All right. So at what time they'll meet? It was 6 a.m. So there is a gap of 3 hours. So they'll meet 6 plus 3, 9 a.m. I hope this is clear to you. All right. Now, so can we formulate this? What is the formulation? Formulation is time taken to meet will be what? Right. So if I say time taken to meet, can I say time taken to meet? If you look it very much carefully, time taken to meet is what? At 6 a.m. What is the distance between these two cars? It was 120 kilometer. So the distance at the start divided by the relative speed. What is the relative speed? 30 plus 10, that is 40. So 120 by 40, 3 hours. All right. So time taken to meet will be what? Time taken to meet will be distance at the start divided by the relative speed. Fine. So at the start, what is the distance? That is 120 kilometer divided by the relative speed. So distance at the start divided by relative speed. But please remember, this is subject to a condition. What is the condition? This formula is applicable subject to a condition. The condition is, this formula is applicable when the starting time is same. So here the starting time is same. The person from Jamshedpur, it started by his car at 6 a.m. and the person from Ranchi started at 6 a.m. The starting time is same, so I can use that formula. So it will be 120 starting at 6 o'clock, the 120 kilometer divided by the relative speed. So please remember, this formula is applicable when the starting time is same. So what I wanted to mean is, starting time same means what? It is when they are starting simultaneously. All right. So this is applicable when or if starting time is same. All right. Now let us understand something more, or something more interesting rather. So I hope this part is clear to us. At what time they'll meet? They'll meet at 9 a.m. and the time of travel is how much? The time of travel is 3 hours till they are meeting. All right. Now just tell me one thing. There are three entities basically in time, speed, distance chapter. This will be speed, distance, and time. Now, out of this speed, distance, and time, just tell me one thing. For these two cars, which entity is same till they are meeting? From the start till they are meeting, which entity is same or which entity is constant? So that will be the time of travel, because this car has traveled 3 hours to reach somewhere over here. This car also has traveled 3 hours and they met. Alright. So time of travel is same. So if time of travel is same, so I hope you know the proportionality part of this. So if you look at the proportionality, so we have got distance equal to speed into time. If time is constant, can I say that distance and speed are directly proportional? Alright, and if that is true, let us see how it is true or not. So let us understand what is the distance traveled by this car till it is met at the starting point. The distance traveled by that car is 30 into 3, 90 kilometer. Now distance traveled by this car till they meet, it is 10 into 3, 30 kilometer. Now, can you say that distance and speed are directly proportional? So that means the ratio of distance travel should be equal to ratio of speeds. So what is the ratio of distance travel? The person from Ranchi to person from Jamshedpur. Ratio of distance travel. The ratio of distance will be 90 by 30. This is 3:1. Now look at the ratio of the speed. Ratio of the speed is 30:10. So that is also 3:1. Alright. So it will be equivalent to 30 by 10. 3:1. Alright. I hope this part is clear to us. Okay. Now the first example, whatever I have given you, the example is with respect to the starting time is same. Now let us understand the next example. The next example will be the starting time is not same. So how do we solve the question? It's quite simple. Let's have a look. So please remember, if starting time is not same, you cannot use this formula directly. So I have to do something else. So let's have a look. So let us put this way, that the person from Ranchi is starting at 5 a.m. Not at 6, starting at 5. Alright. So this person started at 5 a.m. So starting time is not same. Now, at what time they'll meet? That is the question. So let us understand how do we handle. Fine. So what I am supposed to do? This formula is applicable when the starting time is same. So let us move this car till 6 a.m. If I move this car till 6 a.m., then I can say that starting time will be same, because that car is starting at 6 a.m. So that means, what is the process or what is the rule? The person or the car which starts earlier, let the car move till the other person is starting. Fine. So other person is starting at 6 a.m. So let it move for 1 hour. So if it moves for 1 hour, so at 6 a.m. it has traveled 30 kilometers. Fine. So can you see now the situation is what? This car at 6 a.m. will be here, is 30 kilometers ahead, and this car is starting. So can you say at this moment, I can say that the starting time is same for both. So I can, from 6 a.m. I can use this formula. So what is the distance at 6 a.m. between these two? 120 kilometer minus 30. So this comes out to be 120 minus 30. That is 90 kilometers. So I can use this formula. So beyond 6 a.m., what is the time taken to meet? It will be distance at the start, that is at 6 a.m. divided by the relative speed. So time taken will be what? Time taken to meet beyond 6 a.m. Please remember, here it is beyond 6 a.m. So this comes out to be at 6 a.m. What is the distance? The distance is 90. And what is the relative speed? 30 plus 10. So this comes out to be 9 by 4 to 1 by 4 hours. So 2 1 by 4 hours means 2 hours. 1 by 4 hours means 1 by 4 into 60. That is nothing but 15 minutes. So 1 by 4 hours is nothing but 1 by 4 into 60 minutes. So 15 minutes. So it comes out to be 2 hours 15 minutes. Alright. Now, at what time they'll meet then? From 6 a.m. it has traveled 2 hours 15 minutes. So that means from 6 a.m. two hours 15 minutes. So this comes out to be 8:15 a.m. So they'll meet at 8:15 a.m. Is that clear to us? Do you have any question to ask? Or it's all right? Okay. So we have learned these two things, which talks about if the starting time is same, and it talks about if the starting time is not same. And now the first thing what we have learned is if both the cars are moving in the opposite direction, right? So if both the cars are moving in the opposite direction, relative speed is sum of their speeds. Now let's talk about if both the cars are running in the same direction. Now before I proceed, if both the cars are running in the same direction, so what kind of examples I can have? One is if you are driving and if you are trying to overtake. So when you are trying to overtake, there is a car in front moving this way and you are also moving this way. Fine. So there is a question of or situation of running in the same direction. All right. So there can be more examples. Say for example, you are being chased by your friend. All right. So you are running and your friend is also chasing. Chasing means what? Moving in the same direction. Right. Now please remember one thing in this case. You have to use a little bit of common sense. Fine. Now the person who is behind. Right. So if the speed of the person who is behind, if the speed is more than the person who is ahead, so in that case, they'll definitely meet. Fine. So let me tell you a little bit more elaborately in a different example. Say if you want to overtake a car. So a car is in front of you, is traveling. Now, if your speed is more than the speed of the car in front of you, then only you can overtake. So overtaking means running in the same direction and meeting. Okay. So similarly, if I'm talking about you are being chased by your friend, so can you understand this way that if the chaser's speed is more than the person in front, then they'll meet. And if the person in front, whoever is running in front, the speed of the person in front is higher than the speed of the chaser, then definitely they'll not meet in a straight line. So if it is linear distance, so they'll never meet because they'll increase the gap. Now, if the person in front is having higher speed with respect to the person behind, they can meet if it is a circular path or circular track. So when we'll be learning circular motion, we'll be learning that. Okay, so not now. So let's talk about running in the same direction. So if running in the same direction, let me explain first why it is the difference of the speeds. So if running in the same direction, the relative speed is difference of the speeds. So let me explain first and then we can have one question. So let's say generally running in the same speed, you get questions with respect to police is chasing the thief. So let me talk about a police and a thief. Police is chasing a thief. Fine. So there's a police over here and there is a thief over here. Police is chasing the thief. The speed of police, say for example, is 40 kilometer per hour and it started at 5 a.m. and speed of thief, let's say 10 kilometer per hour. So thief is moving this side and police is chasing. All right. Now let's say the distance when police started chasing the thief. That means if it is 5 a.m. so that means at 5 a.m. the distance between police and thief, let's say 150 kilometers. Okay. Now let us understand this way that let's take this is a 0 point. So this has to be 150 kilometer point. Fine. Now after 1 hour what will happen? Have a look. After 1 hour what will happen? So after 1 hour this police will be 40 kilometer ahead and this thief will be 10 kilometer ahead. So if I put a scale, that is 0, 150 kilometer ahead, this is 150 kilometer. Now after 1 hour, that means at 6 o'clock, the thief will be somewhere over here. At 6 o'clock, thief will be somewhere over here. So this is 10 more. So this is a 160 mark. Okay. Now the police after 1 hour will be traveling 40 kilometer. So police will be 40 kilometer ahead. So police will be at 6 a.m. It will be 40 kilometer ahead. Now let us understand at 5 a.m. what is the distance between police and thief? This was 150 kilometer. Fine. And after 1 hour, what is the situation? The situation is police is at 40 mark and the thief is at 160 mark. So what is the gap between police and thief at 6 a.m.? So can I say 160 minus 40? So this comes out to be 160 minus 40, that means 120 kilometer. So can you see the gap is reduced? Yes or no? The gap is reduced. Now gap is reduced by how much? The gap is reduced by 150 minus 120. That means 30 kilometers. Alright. So relatively they are reducing the gap at the rate of 30 kilometer per hour. Fine. Now this 30 kilometer has come from where? This police has gone ahead by 40 kilometer, and if thief has gone ahead by 10 kilometer, so relatively the gap is reduced by 40 minus 10. So 30 kilometer. So gap is reduced by 30 kilometer. 150 minus 120. That's 30 kilometer. Alright. So what you have understood? If they are running in opposite direction, then what is the relative speed? Relative speed is difference of their speeds. So, and please remember, you have to use your own common sense over here. If the chaser speed is more than the person in front, they'll definitely meet in a straight line. Or if the person in front is having more speed with respect to the speed of the chaser, then in a straight line, they'll never meet. They'll increase the gap. All right. So what is the relative speed? Relative speed comes out to be difference of their speeds, and this is nothing but 40 minus 10, 30 kilometer per hour. So that means they are reducing the gap at the rate of 30 kilometer per hour. So after how many hours they'll meet? Once again, the formula was same. It was applicable. It was the same formula. So what is the formula? The formula says that the distance at the start, the starting is same, 5 am and 5 am. Distance at the start divided by relative speed. So what is the distance at the start? 150. 150 divided by 30. So 150 divided by relative speed is 30. So that will be 5 hours. Now, if you don't want to understand in this form, you can use unitary method also in the same fashion. So what is happening? Initially the gap was 150 kilometer, and per hour they are reducing a gap of 30 kilometer. So they are meeting means what? The gap should be 0. So other way around, if you use unitary method, can I say 30 kilometer is reduced in 1 hour and 150 kilometer is reduced in how many hours? If you reduce 150 kilometer, that means you are meeting. So the police and thief are meeting. So the gap is 0. So it will be 1 by 30 into 150. And that's not nothing but this. All right. Okay. So that's what it is talking about with respect to relative speed running in the same direction. Okay, I'm not giving other examples where the starting time is different. I hope you can understand, you can solve, right? Because starting time, if starting time is different, so how do we handle? We have already discussed. So use that funda accordingly. Fine. Now let's take an interesting example. Achha, before we get into an interesting example, can you see some other factors over here? So till they are meeting, which entity is constant for these two, police and thief? Time of travel is constant, or time of travel is same. Both police and thief traveled 5 hours. So once again, if time of travel is same, that means the ratio of speed is nothing but ratio of distance traveled. Okay. Now let's have a look. 5 hours. So if when thief has traveled 5 hours, after 5 hours, police will catch the thief, right? So if thief has traveled 5 hours, he has traveled how much from here? Travel somewhere over here. This will be 50 kilometer, 5 into 10. All right. So this is the meeting point, or this is the point where police will catch the thief. Fine. Now let us see what is the distance traveled by police and thief. Distance traveled by police in 5 hours will be how much? 5 into 40, 200 kilometer, and distance traveled by thief will be how much? 5 into 10, 50 kilometer. All right. So ratio of distance is what? Ratio of distance will be 200 by 50. So 4 is to 1. Ratio of speed is what? 40 is to 10. So 4 is to 1. So ratio of distance travel is equal to ratio of the speeds. All right. So here also we can find similar type of situation where the time of travel is same. If they are running in opposite direction till they are meeting, the time of travel is same. If they are running in the same direction, If the starting time is same, so till the meeting point, the time of travel is same. Fine. If time of travel is same, so ratio of speed is nothing but ratio of distance traveled. All right. Okay. So now let's take a question rather. So this question came in CAT, and the question is quite interesting. And of course, which is connected to this theory. So let's start. So let me tell you the question first. The question is something like this. There is a tunnel, there is an entrance of the tunnel, and there is an exit of the tunnel. Fine. And a cat is sitting inside a tunnel. So there will be some data. I'll tell you the data. Now, a train is approaching towards the tunnel and definitely towards the entrance of the tunnel. Fine. Now, train whistles. Now, after hearing whistle, the cat runs either ways. The cat can run towards the entrance of the tunnel and cat run towards the exit of the tunnel. So the data says if the cat runs towards the entrance of the tunnel, the cat and train meets exactly at the entrance. And if the cat runs towards the exit of the tunnel, then the train and cat meets exactly at the exit. So the question is, what is the ratio of speed of train to speed of cat? So let me draw the whole thing. So I'll explain once again. So the question says there is a tunnel and this is the entrance of the tunnel. In the question, of course, there is no drawing, and this is the exit of the tunnel. This is the exit of the tunnel and this is the entrance of the tunnel. Say the total length is L. Length of the tunnel is L. Now a cat is sitting inside, which is 3 by 8 L away from the entrance of the tunnel. So cat is sitting here, which is 3 by 8 L away from the entrance, and where L is the total length of the tunnel. Now a train was outside, somewhere over here. So let's say the train is over here. Fine. Train whistles. Now there are two situations are given in the question. After hearing whistle, cat starts. Now it says that if cat runs towards the entrance of the tunnel, so the train and the cat meets exactly at the entrance of the tunnel. And second case says, after hearing the whistle, if the cat runs towards the exit of the tunnel, then the train and the cat meets exactly at the exit of the tunnel. All right. Now, please understand this way. Can I say that once again there is a point of meeting comes in over here? Fine. Can I say that this train and cat in the first case running in opposite direction and meeting somewhere over here, and in the second case cat is running this way and train is also running in the same direction and they are meeting over here? All right. So once again there is a situation or there is a case of meeting, right? So now let us understand this way. Now can you say that time taken by cat to travel this 3 by 8 L should be equal to time taken by train to travel this distance? So let's take this distance as y, because they are meeting. Fine. If they are meeting, so time of travel should be same till the midpoint, right? So till meeting point, if time of travel is same, so can I say that speed of train by speed of cat should be equal to ratio of the distance traveled? So what is the distance traveled by train? Y. And what is the distance traveled by cat? 3 by 8 L. Is it okay or is it acceptable to you? Alright, so this is for case number 1. Case number 2 says what? Case number 2 says if the cat is moving this way, so that means the time taken by cat to travel from here to here is equal to time taken by train to travel from here to here. Achha, what is this distance? This distance is 5 by 8 L. Alright. So, if the distance is 5 by 8 L, then can you say that if time of travel is same once again, so speed of train by speed of cat is nothing but distance traveled by train by distance traveled by cat. So speed of train by speed of cat is nothing but distance traveled by train is how much? Y plus L divided by distance traveled by cat is 5 by 8L. Now if we equate these two, I'll get the answer. Okay, I'll be having a relationship with respect to Y and L. I put over here and I'll get the answer. So let's have a look. So the question is what? Question is, what is the ratio of speed of train by speed of cat? So please equate these two. So I'll get Y plus L. Why should I equate these two? Because in both the cases it is speed of train by speed of cat. So speed of train by speed of cat has to be same in both the cases. So y plus L divided by 5 by 8L should be equal to y divided by 3 by 8L. So if I simplify L and L has gone, sorry, L by 8 I can, right? So I can put directly y plus L divided by 5 should be equal to y by 3. Now simplify this. If you simplify this, I'll get 5y equal to 3y plus 3L, or I can say this will be 2y equal to 3L. Alright. Is it okay? Is it clear to us? So now replace over there. So have a look. So finally I can get the answer. I put these values over there. So what is my answer? The answer is speed of train by speed of cat will be y divided by 3L by 8. 3L is how much? 3L is 2y. So y divided by 2y by 8. I can divide both numerator and denominator by y because y is not equal to 0. Right? So y cannot be 0. If y is 0, the train is supposed to be here only, no? So definitely the train was some distance away from the entrance. So y cannot be 0. So I can divide both numerator and denominator by y. So please remember, in your aptitude calculation, when you divide something from left side and right hand side or from numerator and denominator, you should be sure that the value should not be equal to 0. Otherwise, you cannot. So this comes out to be 8 by 2 and 4 is to 1. So your answer is 4 is to 1. So this is the orthodox method to solve the question. Now let me tell you another interesting method where I am not supposed to write all those, and I can say there will be a shortcut method. So let's look at that. I hope this part is clear. So let's look at the shortcut part. So when you look at the shortcut part, let's understand this way. The cat was 3 by 8L away from the entrance. Now if I can take L equal to 8 kilometer, so I get an integer distance over here. So let's take the length of the tunnel is 8 kilometer. See, you can take 8 kilometer or any multiple of 8 kilometer. If you take 8 or any multiple of 10, 8, then you will be having integer value. That's it. So let's take L equal to 8 kilometer. So this distance will be how much? 3 by 8 into 8. So this will be 3 kilometer and this will be 5 kilometers. Fine. Now look. In the first case, it is telling that when cat has traveled 3 kilometers, it made the train exactly over here. So can you say that the time taken by cat to travel 3 kilometers is nothing but time taken by train to travel y kilometer that we have already discussed? Now let's understand physically. Physically, we can understand this way. When cat has traveled 3 kilometers, the train was exactly over here. Alright. Now come in the second case. In the second case, this 5 kilometer I split in 3 plus 2. Now in the second case, when cat was here, That means when cat has traveled 3 kilometers, where was the train? When cat has traveled 3 kilometers, in the first case, when cat has traveled 3 kilometers, it made train at the entrance. This side, when cat has traveled 3 kilometers, the train was exactly at the entrance. Is that clear to us? Now, from this moment, can I say that the time taken by cat to travel 2 kilometers is nothing but time taken by train to travel 8 kilometers, because both train and cat meets over here. That means, so time taken by cat to travel 2 kilometers is nothing but time taken by train to travel 8 kilometers. So once again, time of travel is same from this moment. So if time of travel is same, the ratio of speed is nothing but ratio of the distance traveled. So speed of train by speed of cat is nothing but 8 kilometer by 2 kilometer. 4:1. Okay. So this is quite interesting thing. Fine. Anyway, so today as of now this much. Thank you very much.